Okay, so let's start, guys. Okay, so good afternoon, everybody. Let's start. So last time I started to teach branch and loop instructions. I told you branch instructions are used to make conditions. You remember in C language, we used to make condition, something like if A is equal to B, do this one, else do something else, and so on. So I'm gonna elaborate today. You are gonna see, I'm gonna teach the statements you used to do in C language, like if statement, if else, switch case, for loop, while loop, do while. I'm gonna show you how can you do the same thing in assembly. Okay. So last time I told you if you want to make a condition something like that, you have to do it in two instructions, usually two steps. Step number one, you have to update the flags. Okay, you have to update the flags. If you want to make comparison. And number two, you have to use one of the branch instructions. This branch instruction is gonna check the flags, and based on the values of the flags, this instruction is gonna make the decision either branch or not. Okay, so usually we have to do two this way. I give you a very simple example before to understand what I'm saying. So if I want to do something like that, if A is equal to 2, okay. So if you want to do something like that, number one, I have to do subtraction. Update the flags. Number two, I have to select a branch instruction that is branch if equal. Okay, so we have different branch instructions. They are going to do different things. Branch if equal, this one is going to branch if the zero flag is 1. And if the zero flag is 1, it means A is equal to 2. You got what I'm saying? So here I just want to give you a simple example about equal. So if you want to do something like that in assembly, you have to do it in two steps. First, you have to do subtraction, and just to update the flags, and then you have to use one of the branch instruction here that is gonna check the flags, and then it's gonna make a decision either branch or not. Okay, I give you here example for this instruction. This instruction only is gonna look only at the zero flag. Is that okay, guys? Okay, so now I'm gonna elaborate. You can do the same thing here. I'm talking about equal. We have another one, it's called non-equal. We have greater or equal. We have less or equal. So we have different. It depends on what you want to do. Okay. So now for this instruction here that you need to update the flags. Okay, I told you can use subtraction. I'm totally fine. You can use subtraction. However, subtraction is you are gonna subtract, and then you are gonna store the result somewhere, as we explained before. Here, I'm not interested in the difference. I'm not interested. I just want to update the flags. You got what I'm saying? That is why it's totally fine. If you want to use, it's not wrong to use subtraction. But which is subtraction? We have two subtraction. If you use this one, it's wrong. If you use this one, it is okay. I know, I think you know what is the difference, right? This one is going to update the flags. This one is going to do subtraction. It doesn't update the flags. But anyway, it's going to work if you use this one, but it's not good idea to use subtraction anyway, because subtraction is going to change. It's going to store the result somewhere. Okay, here I don't want to store the result. That is why they created a special instruction here. We call it compare instruction. CMP, compare instruction. And this one doesn't have S, and you don't need to do S. Why? Because this instruction is used to update the flags. So it has only one version without S. Okay, so this one is gonna because if this one doesn't update the flag, it doesn't do anything, right? Anyway, so you need to use compare here. Okay, guys. So we have compare. We have three other things in addition to compare. maybe what we are going to use all the time is compare and test instruction. There is another two. I'm gonna go through them quickly, but these are the very famous ones, okay? Or the ones we are going to use most of the time. So you can use compare, guys, if you want to test if it is equal, if it is greater, if it is less. If you have two numbers and I want to compare between them, greater or equal, less or equal. So in this case, use compare, okay? And you need to test. Test is used first. What test is going to do? What test is going to do is going to do AND, bit by bit AND. So you should have two registers, okay, or register and a number. So for example, R0 and 1, and then it's going to do bit by bit AND again, and it's going to update the flags. It's not going to store the result anywhere. So it's the same idea like subtraction. It's not going to store the result anywhere, but it's going to update the flags. Okay, so it's going to do bit by bit AND. Okay, how this one is useful, because I almost finished the coming lab. I'm going to post it after the lecture, so you are going to need it in the coming lab, this test. Okay, so I think I made it very clear. If you want to do something like that, you use compare, equal, greater, less, whatever. Okay. However, test is going to be used if you want to check some bits, if they are ones or zeros. Okay, guys. So in the coming lab, there is one task. I'm asking you to check bit number 5. So bit number 5, I want you to check bit number 5. Is bit number 5, is it 0 or 1? How can you do it? As I explained to before in AND. All what you have to do, guys, here you have to put 1, and then you have to put 0 everywhere. Is that okay? And now there are two options. Now, if the 0 flag is 1, what it means? If the 0 flag is 0, what it means? Okay. If the 0 flag is 1, that means the result is 0. That means 0, 0, 0, 0. Okay. That means bit 5 is equal to 0. You got what I'm saying? So if the 0 flag is 0, that means bit 5 is equal to 1. Conclusion, again, very simple. If you want to check some bits, you have to use test, because test is going to do AND. The result is not going to be stored anywhere. And then after test, you can do it checks the 0 flag. You know who's going to check the 0 flag? Branch if equal or branch if not equal. Okay. If you want to do comparison, greater or equal and so on, something like that, in this case you have to use compare, and after that one of the branch instruction. Okay, guys, any questions? I'm going to give you more detail. Yeah, I'll go through them, and we're going to have a lot of examples today to understand better. After I finish this section, you should be able to do the same statements you used to do in C language. You should be able to do it in assembly. That's it. That's the purpose of this section. How can you do while, for, do while, switch case, if else, if if, and so on. Okay. One of the things also I said last time, after use compare, actually you can do one of two things. You can use branch, conditional branch. So I want a branch if A is greater or A is less, whatever. Okay. Or you can write here conditionally, what we call conditionally executed instructions, as I'm going to elaborate right now. Okay, a conditionally executed instruction. Okay, so we have most of the instruction I taught, you can make them conditionally executed. What this means? It means I want to do addition, but I want to do addition if A is equal to B. Condition. So here, in this case, as you will see right now, you have two options. Again, I want to do something if A is equal to B, for example, R0 equal R0 plus 1. So I want to increment R0 by 1 if A is equal to B. Okay. To do this part, you have two options. Number one, I can use compare, and then I can use branch. And if the condition is true, I'm going to branch to somewhere. And then here, I'm going to write these instructions there. Okay, so I'm going to branch to here if the condition is true. And then here, I'm going to write the instruction I want to execute. This is one way. The other way is, after compare, I'm gonna say add if equal. Add if equal. So how is this one different from add instruction we had before? You can tell. The add instruction we had before is gonna add all the time, but this one conditional add. So this one is gonna add if they are equal. Okay, you will see right now the difference. So let me go through what I said before I give you. We have a lot of examples here, and the examples are important to understand what I was. So here, guys, yeah, as I told you before, number one, for branches, we have unconditional branches and conditional. You can tell from the English name. Unconditional, you can branch all the way, okay? Here I'm explaining four, but actually in this section we need only one, because these ones are going to be used with these ones are going to be used with subroutines, as I'm going to explain later. So let's focus in this one. This one is unconditional branch. So for example, if you see here, guys, B means branch to target. So every time I come here, unconditional, I'm going to come here all the time. Okay, all the time the branch is taken because there is no condition. Okay, you will understand. So that means if you come here, you want to skip this part. Okay, yes, someone should ask, because this is not the complete picture. Okay, but that's why you can ask me. So why I have to write something here as long as I'm gonna skip it all the time? Okay, my answer for now, you will understand it right now. But my answer for now is, if you have if statement, for example, so here then, or this is the body of if. So I'm gonna write some instructions here. And here else. So I'm gonna put here a condition. And based on the condition, if I'm gonna go to the else, the body of else, or I'm gonna go to the body of if. Right? This is normal if else statement. So if the condition is true, I have to execute this one. So you have to write, if I execute then, so I have to skip to here all the time, because it doesn't make sense to execute the body of if and execute else as well. It shouldn't happen. So if this part is executed, I need to skip this part. So in this case, as you will see right now, I'm gonna say branch in the if, so that if I come here, all the time I have to skip this one. Anyway, so this is the first one, we call it unconditional branch. Please, if you have any question, don't be shy, just raise your hand and ask me, okay? So now, I told you, you need to update the flex. Last time I explained these 4 instructions, but I'm gonna focus mainly on compare and test. That's what I told you, compare and test. For compare, you can put here a register and you can put here a register as well. Or here it should be a register anyway. So this one register anyway. This one can be a register or it can be a number. Okay, a number. Same thing for here. You can be a register or a number for test. Okay, test actually is gonna, this one actually is gonna do end, as I told you. Okay, we have another instructions here that may not be one maybe you're not gonna use them a lot. So one of them here, you are gonna compare, but with not of the second element. So the one's complement of the second element. Okay, this one is gonna do XOR. So this one is gonna do XOR between these 2 numbers. I told you before, this one can be, you can use it if you wanna check if R1 is equal to R2. For example, two registers are equal, because if two registers are equal, if you do XOR, you are gonna get 0, 0, 0. Okay. Again, you can do this way, or you can do compare. You can subtract. So if I want to know 2 registers are equal or not, I can do subtraction or I can do XOR, right? So that's why I told you most of the time we're going to use this one and this one actually. Anyway, then I told you guys about the branch instructions we have. So this, yeah. So here, these are all the branch instruction we have. They are similar to this slide, but you just add letter B. So here, if you want to branch if equal, you can just add letter B here. So this one is going to branch if equal. So, but let me tell you, make some simple classification to these branches. Listen to me. Number 1, I need to branch if equal, right? That's what I have. I need if it is not equal, right? Also, I need for greater, for less, greater or equal, less or equal. Okay, that's what I need. For equal, we have only one, equal. So you can say branch if equal. For not equal, we have only one, branch if not equal. Is that okay? For greater, we have two. For less, we have two. Greater or equal, we have two, and we have two. For every one of two, we have two. Why you have two? One for signed numbers, the other one for unsigned numbers. Is that okay? Because it matters. I give you a very good example to understand what I'm saying here, guys. If I want to compare between this number and this number, if I want to test if this one is greater or not, the decision is going to be different if signed or unsigned. I think I explained it before here. So if this number is unsigned, so actually this one is greater because this one is negative one. Sorry, if it is signed, this one negative one and this one is one. However, if it is signed, if it is unsigned, this one is greater. Okay, that's why we have two different instructions, one for signed and one for unsigned. And hardware doesn't know if your numbers are signed or unsigned. That's what I said maybe in the first or second lecture. Okay, the hardware doesn't know. So this is, as a programmer, you have to select the correct instruction. You got what I'm saying? That's why in the coming lab, the last task in the coming lab, I give you an array. I tell you in the array, I want you to store 0, -1, 100, -7, 9, and so on. I don't need to tell you this is signed numbers because it has positive and negative, right? I wrote it in the lab anyway. Just so I wrote it in the lab. It's very obvious that these numbers are signed numbers, right? So that means if you want to do any comparison, you have to use the branch instructions for signed. Is that okay? So here, and I told you the way you are going to do it, guys. We have here, we are going to use the English word greater, greater than, okay? So here, if they are signed, this one should be greater than, this one should be higher. So here we are going to say branch if greater than, branch if higher, branch if greater than or equal, branch if higher or same. So here you can see in case of sign, you use the word equal. In case of unsigned, we use the word and we use letter E, as you see here. Here we use, instead of equal, you will use same, like S here, as you see S here. Also, here we use greater, G. You can see letter G here for greater. Here we use H for higher, and so on. It doesn't matter for sure in case of equal or not equal, it doesn't matter. Makes sense? Because equal is equal, right? Doesn't matter if it should have the same bits. It doesn't matter if signed or unsigned. Okay, guys, any questions? Again, very simple. If you want to compare, if you want to do comparison between number, if A is greater than B, very simple. If your numbers are signed, so you have to use one of these. If your numbers are unsigned, you have to use one of these. That's it. Otherwise, your program is not going to give good, correct results. Okay. So now, okay. So here, if you look at what we have here, guys, I told you we have here equal. We have not equal, we have greater, less, greater than or equal, less or equal. Okay, we have more instruction to check the flags. We have some instruction to check the flags, and you are going to branch if the flag is 0 or 1. Okay, that is so, as you see here, guys. See as branch if carry is set. So we have, let me go to this one. Thank you. Yeah, look here. BCS. So this one, you are going to branch if carry is clear. Set. If the carry is 1. This one, you are gonna branch if carry is clear, 0. So these two instructions are going to check the carry flag. These two instructions, equal or not equal, is going to check the 0 flag. Is that okay? So also we have here branch if minus, branch if plus. So these two are going to check the any flag, negative flag. So this branch is going to be taken if the negative flag is 1. This one is going to be taken if the negative flag is 0. Okay. And we have 2 more instructions to check the V flags. Okay, guys. So again, What I'm saying here, we have some branch instruction to check the individual flags, every flag, if it is 0 or 1, right? We have instruction to do comparison, like greater, less, or greater or equal, less or equal, or equal or not equal. Yeah, so we have this as well. Okay. In the coming lab, you are gonna need branch if carry if set, or branch if carry if clear. How? Okay, so you actually, one of the tasks you are gonna do here, I'm asking you to if you have a word, if this word has some ones and zeros, a word, we want to count how many ones, I don't remember, ones or zeros. Okay, so you have a word, and I want to count how many ones we have in this word. I want to count how many ones, number of ones. How can you do it? Very simple. Look here, guys. Number one, I have to do shift instruction. Once I do shift, so actually this guy is going to go to the carry. Then I'm going to check the carry. If the carry is 0 or 1. If I want to check the number of 0, so I'm going to increment the counter if the carry is 0. If I want to count the number of ones, so I'm going to increment the counter if the carry is 1. So every time you shift, so you are going to take one guy, you are going to take one bit here, you are going to take one bit in the carry, and then you can check the carry if it is 1 or 0, right? You already have an instruction to check the carry if it is 1 or 0. Okay. How many times I have to do this one? How many times? How many times? 32 times, right? Because we have 32 bits for every bit. So I have to take it for every. So that's why in order to do this one, you have to do for loop. And shortly, I'm going to explain how can you do for loops. So you are going to do for loops 32 times. Every time you shift, once you shift, I'm going to take one element is going to go to the carry. And then I'm going to check this one if it is 0 or 1. Okay, this is one task in the lab. Anyway, so again, this is all what I have here, but you are not going to understand what I said completely until you see examples. That is why from here until the end of this section, you are going to have a lot of examples to understand it. Okay. Look here, guys. If I do something like that, look here, guys. I'm going to do here, compare R0, R1 and R0. Okay. I told you, as you know, here you are going to do R1, take away R0, as you see here. You subtract R0 from R1. So that's okay. And then I told you, after this one, you can do one of two things. I can do conditional branch, or you can do conditionally instructions. And that's what I did here. So here I'm going to say add s. You know what add s is, but I'm going to add this part here, BL. This is a new part. So we already know this part, but this is a new part. So now this instruction became conditionally instruction, or conditionally executed instruction. So here I'm saying here, if it is plus, if the result is plus, okay, R1 minus R0. If the result is plus, you know plus what plus means? Plus means the negative flag is 0, right? Because this one is gonna check the negative flag. Okay. So when the result of this one is gonna be plus, okay, this one is gonna be plus when R1 is greater than or equal R0, right? If this is true, please do this addition. So this instruction is not gonna add all the time, right? It's gonna only add if the condition is true. If R, so this one, if R1 greater than or equal R0, you are gonna do the addition. If not, if the result is, if the negative flag is 1, not 0, so you are not gonna execute this. This instruction is not executed. Is that okay, guys? Again, as you will see later, you can do this way, or you can do branch, whatever you like. I'm totally fine. Maybe this one has some problems I'm going to explain later, but you can also do branch. So you can branch. You can see here, for example, branch if greater or equal. So if greater than or equal, okay, you can branch, for example, to then, and then in then you can do the addition. Something you will see examples now. Okay. Let's see another example here, guys. If I want to do absolute value, if I want to get the absolute value, you know, to calculate the absolute value, if the value is positive, I don't need to do anything. If it is negative, so I have to multiply it by -1 to make it positive. Okay, this is the meaning of absolute. So that's what I did. Look what I did here, guys. I'm gonna compare R1 to 0. Then I'm gonna say do reverse subtraction if less than. So if R1, so this one, if R1 less than 0, okay? So in this case, you have to do reverse subtraction. So what this instruction is gonna do is gonna be 0 minus R1. It's not R1 minus R, it's not R1 minus 0 because this is a reverse, okay? So that means you multiply R1 by -1. So if R1 is less than 0, this instruction is gonna be executed to calculate negative R1. Any questions? By the way, if you use this one, this is a big mistake. Don't do it, please. For example, here I decided to use this one, less than. If you use this one lower, it's wrong. Okay? Because this one is going to be used if the number is unsigned. But now the number, in this problem, the number can be positive or negative, right? If it is positive all the time, I don't need to calculate the absolute, right? So here, in this case, this number can be positive or negative. Okay. Anyway, I have another example here, guys. For example, I want to do 64-bit sign extension. Okay. I told you about sign extension before. Okay. So sign extension means if your number is positive and you want to extend it, you just put zeros here. If your number is negative and you want to extend it, you have to put ones here. Is that okay? Okay. So now I'm assuming my number is 64. 64, so we have here R0 and we have here R1. My number is already in R0. My number is 32-bit. I want to extend this number to 64. How can you do it? Very simple. If this number here is positive, so I'm going to put here zeros. If this number is negative, so I'm going to put here ones. Make sense? So your number is 32 bits. I want to extend it to 64. Is that okay? So I need to check. I need to check the number. If the number is positive, so the other 30, because this is the number here. The number is 64, R0 and R1. Okay. So that's what I did. If you see here, guys, again, if you want to see if this number is positive or negative, you can compare to 0. It's totally fine as I did here. You can compare to 0 to see if this number is positive or negative, or you can simply check the sign bit. It checks the last bit. Okay. Again, both are okay. So here I want to know if the number is positive or negative. That's why I used to compare. Here I'm gonna check the last bit. I'm gonna check the sign bit, and that's what I did. So if you see here, guys, I want to check the sign bit. So I'm gonna put here 1. I'm gonna put 0 everywhere, and this number actually is 8000000. This one. Okay. So now I'm gonna compare test. I don't think this one is gonna work. I think you have to put here hashtag. I want you to try it, but I think you need to put here hashtag. You can try, see what's gonna. Anyway, so now, as you see here, guys, after this test, if the result of this test is 0, if the 0 flag is 1, what it means? It means this bit is 0. It means it is positive, and that's what I did. Look here, guys, what I did. I'm gonna say here, load if equal and load if not equal. If it is equal, load R1 with FFF, right? If it is not equal, load it with 000. Is that okay? I think, yeah. I'm sorry, I think there is some mistake here. Because if it is equal, if you put here 1 and 000, if the result is equal to 0, the 0 flag is 1, and this is what equal is gonna do. If the 0 flag is 1, that means this bit was 0, right? If the 0 flag, yeah, so I think so that means if this bit is 0, I think I switched them. I'm sorry for that. So here, yeah, I switched them. Makes sense? So again, what I'm saying here, if it is equal, okay, equal means the 0 flag is 1. So result is 0. That means the bit is 0. If the last bit is 0, that means the number, so I need to switch this. Okay? So here you have to put zeros here. or you can, instead of equal, make it not equal, and this one is equal. Okay. Please fix it. Also, I'm gonna fix it. Okay. Sorry, because this is first time I teach this ARM processor, so sometimes there are some typos. I'm gonna correct them. Okay. Now I'm gonna explain to you guys how can you do something like that in C language. If statement, right? So if I want to do something like that, if A less than 0, so A should equal 0 minus A. Okay, so if not, don't do it. Okay, you know how if statement works, right? If you have a condition here, if the condition is true, I'm going to execute the body of if. If the condition is false, I'm not going to execute the body of if, because this one is outside the body of if. So this one is going to be executed no matter what, right? So regardless, this one regardless of the condition. Okay. So in order to do this one, I can do this way. Look here, guys. This is a very easy way. Here, I'm going to compare A to 0, as you see here. I'm going to compare A. A here means A is stored in R1. Okay. So I'm going to compare R1 to 0. Here also, I'm telling you, your number are signed. So here you have to use greater or equal, whatever. So here I'm going to say, if R1 greater here, look here, guys. I'm going to say if A is greater than or equal 0, not less, greater than. What should I do? If greater than or equal, that means the condition should not be executed. So I have to go to end if. Please skip this one. Make sense? Okay. So here, what I'm going to do, guys, here, I said come to here or skip this one. This one actually is the body of F. So don't execute the body of F or skip this one if R1 is greater than or equal 0, right? If R1 less than 0 is going to come this way, branch, right? Very important to understand the arrows here, the branch here. Greater than or equal 0, so the branch is going to be taken. So if R1 is greater than or equal 0, I have, this is the body of F. So I should not execute the body of F because this condition is false, right? If R1 is less than 0, this condition is false. If it is not, so if greater or equal, the branch is going to be taken. If it is not greater or equal, which means if it is less, so it's going to come this way. Someone should ask me, okay, but based on the logic, everything should work here based on the logic. So what I'm doing here, guys, is that look here. Here, I'm going to check if R0 less than if R1 less than 0, I'm going to come this way. But if R1 greater than or equal 0, I'm going to come this way, and then I'm going to do the addition, this addition, as you see here. Okay. And this is the body of F. I'm going to execute the body of F, which is this one, only if R1 is less than 0. So the logic is true. However, someone can tell me I'm a little bit confused because although the logic is true, although this one is going to do exactly what I want to do here, but I'm a little bit confused because this condition is for less. Here you use the greater, not less. Not less means greater than or equal, right? So here you did greater than or equal instead of less. Although the logic is true, right? The answer is sometimes it's easier to do this way. Sometimes if the condition of if is less, sometimes it's easier to do less. If you need to look for if the condition is true, right? Sometimes it is easier to do if the condition is not true, and that's what I did. So here I'm saying if this condition is not true, come to here, skip the body of F. You understand what I'm saying? So you will see right now, sometimes I program the condition exactly, sometimes I program the opposite of the logic. Okay, so here again, what I did here is if A is not less than 0, skip F. That's body of F. That's exactly what I did here. Any question, guys? We don't have if statement. We don't have for statement. We don't have while statement. But again, we're going to create all of the statements you did before in C language using compare and branch. Okay. Let's see more examples. Okay. Or this is actually the same example. And here here I used the branch, and maybe it's easier to use branch. It's easier to do branch. However, here I want to show you the same example. I'm going to do it using conditionally executed instructions. Okay, look here, guys. In exams, in quizzes, in project, in labs, I'm not going to ask you to use branches or conditionally executed instructions. It's up to you, right? So if you think this is easier, and I guess this is easier, if you think that's easier, it's okay, use it. If you think this one is easier, use it. Okay, so I'm gonna teach the two approaches. However, I'm expecting that you understand this one. So for example, if you give you a program and I ask you what is the result of this program, I can give you something like that. But if you want to program it, it's up to you. You can use, I give you here the same example. I'm going to solve it in two different ways. One using branches, the other way using conditionally executed instructions. When you program it, whatever you think is easy for you, I'm totally fine with it. But you should, I'm expecting you understand. Look how I made it, guys, here. So if I compare this one with the previous one here, first of all, I have to do compare. Yes, here also I did compare, but no branches here. So then what I did here, I'm gonna say, do this part, reverse subtraction, which is execute this instruction if less. So what's gonna happen after compare? We're gonna come here. This instruction is gonna check if it is less, it's gonna do the addition. If it is not, it's not gonna do the addition. Okay. So and then after that, it's gonna come to here. So this instruction, if condition is true, is gonna be executed. Condition is false, is not gonna be executed. Okay. So and this one is gonna be executed no matter what, because after this instruction is gonna come to here to execute this one, and that makes sense because this is outside the body of F. So we need to execute it no matter what. I can have an observation, important. Again, what I'm saying, you can do the same thing using one of two approaches. Branch, like this here, or conditional instructions, like this one. Two approaches, okay? But you can have an observation here. You can see, first of all, this one is too short, right? So very concise. Have only one, if you count how many instructions, this one has more instructions, okay? So this one is very concise. Okay, that's totally fine. However, this one may not work all the time. It works here because the body of F is just you have only one instruction. But if you have too many instructions, it may not work. So this one might not work all the time. But this one for sure, this one can work all the time. Let's have more examples so that you can understand more. I will do my best. I know this topic is a little bit, I don't want to say the word difficult, but it's not as straightforward as if statement, because if statement you have condition true, execute, you have to write multiple instructions, okay? That's it, but it's the same idea. Let's see if I want to do something like that if you have something like that in C language and you want to do it in assembly, how can you do it? Let's first understand how this one works in C language. You remember, guys, in C language, you have a condition here, you have another condition here, right? So you have two conditions. Every condition can be true or false, right? And then the relation between them, or. Okay? They told you in C language, I'm going to execute the body of F if at least one condition is true. If at least one condition is true. Because this is relation or. So if at least one condition is true, I'm going to execute the body of F. Is that okay, guys? So let's do it in assembly. The way we are going to do it in assembly, guys, look here. I'm going to check the first condition. If it is true, so I'm going to execute this one. If it is not true, the first condition, I'm going to check the second condition. If the first condition is true, I don't need to check the second one, right? If the first condition is true, okay. So that means the whole statement is true. I don't need to check the second one. That's exactly what I did. Look here, guys. I'm going to compare R0 to 20, R0x, okay? So I'm going to compare x to R0 to 20. Then I'm going to say if it is less or equal, so if R0 less or equal 20, if x less than or equal 20, please go to then. And then here, this is the body of F. Is that okay? So if the first condition, so this is the first condition. If the first condition is true, okay, I don't need to check the second one. So I'm gonna come to here, execute the body of F. If the first condition is false, if it is not less or equal, so this branch is not gonna be taken, I'm gonna come this way. So less or equal is gonna come this way, greater is gonna come this way. Does it make sense? Okay, when I come this way, now I'm gonna check the second condition, R0 and 25, R0 and 25. Okay, guys. Here it's easier for me to say, instead of greater or equal, to say if it is less, as you will see right now. Look how I made it. I'm gonna say now, let's look at the second condition. This is the second condition here. I'm gonna say compare R0 to 25. If less than or equal, so if R0 less than 25, if you compare this one to this one, that means if this one is false, please go to skip this part, go to indef. Okay, guys? Again, that's programming. You can do it in different ways. But what I did, number one, I'm gonna check the first condition. If it is true, so I'm gonna go to a label called then to execute the body of F. If the first one is false, so I'm gonna execute the second. I'm gonna check the second condition. If the second condition is false, please go to indef, right? Because this one is false and the second is false. Okay, so I just skip this one. So the only way to come to here, the only way to execute this one here, either the first condition is true, I'm gonna come here, or the second condition here is true, so that I can come to here. Because this one, if it is less than 25, I'm gonna skip. If it is greater than or equal 25, it's gonna come to here. Any questions? Again, I wanna tell you, I can do the same thing, but instead of using branches, I'm gonna use instructions, as you see here. Okay, so let's see how I made it. Okay, I did look here, guys. I'm gonna say compare R0 to 25. Yeah, similar to this one. Then I'm gonna say move if less or equal. If R0 is less or equal 20, please store 1 in R. Move 1 to R1. This one. Okay. If the condition is false, so it's not gonna execute the move instruction. It's not gonna execute the move instruction. Then I'm gonna come to here. I'm gonna check the second condition. I'm gonna say compare R0 to 25. If it is greater or equal, if it is true, please store 1 in R1. Okay, guys. So I can do the same thing using branches or using instructions. Okay. Any questions? Let's have more examples. We have too many examples here. Very important to understand this topic, to have too many examples. Let's have another example. Look here, guys. If x is equal to 20 or x is equal to 25, execute this one. Similar to what I did before, this is OR relation. So if any one of them is true, should be true. But here, I'm gonna do it here using somehow like a tricky way, but it's an interesting way. Look what I'm gonna do. Look here, guys. I'm gonna say compare R0 and 20. So this one is gonna do subtraction. It's gonna subtract 20 from R0. That's okay. And then it's gonna update the 0 flag. So update the 0 flag. And then next one here, I'm gonna say compare if not equal. So if the first one didn't update the 0 flag, if the first condition is false, now I need to make a compare for the second one. Let me say it again. If R0 equal to 20, so this one is gonna put 1 in the 0 flag. Okay, and this one is not gonna be executed. I'm gonna come to here, and this one is gonna move if equal. So it's gonna put 1 in R1 if it is equal. Okay. Again, you don't need to complicate this way. Okay, you can just use simple branch. I'm totally fine. But just I want to show you different ways. Okay. However, here I want to show you I can put even condition for compare. So this one only is going to be executed if not equal. If the first to compare, put 0 in the 0 flag. When this should happen when the first condition is false. So if the first condition is false, okay, I'm gonna subtract 25 from R0 and update the 0 flag. Okay. When I come to here, again, I'm gonna check the 0 flag. If the first condition is true, so this one should put 1 in the 0 flag. If the second one is true, so this one should put 1 in the 0 flag. If neither of them is true, so that means the 0 flag is 0 and this one is not going to be executed. Okay. Anyway, again, I personally prefer branches. Just branches are easier, but also you should understand, and this one of the beauty of the ARM processor, because it's just to concise. Okay, instead of writing 3-4 instructions, I can just use one instruction. This instruction actually is going to do this instruction conditional. It's going to check condition and execute also instruction. So it's going to be less number of instructions. But now let's see another example here, guys. And this time I'm going to use AND. So now, as you see here, guys, I have two conditions. X is greater than 20 and X is less than 25. You know from C language, we are going to execute the body of F if the two conditions are true. This is the relation AND. In case of relation AND, it's not enough to check one condition. It's not enough. The two conditions should be true. It's different from OR. In case of OR, if the first condition is true, I don't need to check the second one because I'm looking only at least one of them should be true. But this is AND. Both of them should be true. Okay? You know how I'm going to do it? Okay, I told you, listen to me. I told you. Sometimes when I do the assembly, sometimes it's easier to check the condition, sometimes to check the opposite. If this opposite of this condition, so this condition is greater, sometimes it's easier for me to check if this condition is false, less than or equal. And this is what I'm going to do right now. Why? I'm going to tell you why. Look here, guys. The way I'm going to do it in assembly, I'm going to check the first condition. If the first condition is false, okay, so go to the end of F. I'm done. I'm not going to do the body of F. I am done, right? If false. If not, so I'm going to go to the second one. If the second one is false, I'm going to check if this one is false. If it's false, I'm going to go to the second one. Sorry, if this one is true, if this one is false, I'm going to go to X. I'm done, right? If this one is true, I'm going to come to here. Same thing I'm going to do it here. You get what I'm saying? See how I went it. Look here, guys. Here, I'm going to compare R0 to 20, as you see here. Then I'm going to say less or equal. So if X less or equal 20, so go to endf. Okay, I'm not going to execute the body of F. Go to endf. Make sense? The condition is false. However, if the condition is true, if X is greater than 20, so I'm going to come this way. So the first one is true. Now I'm going to look at the second one. Again, as you see here, I'm going to check the second one. If the second one is false, false means greater or equal. So here I'm going to say if it is greater or equal, go to endf. Okay. The only way to come to here, is this branch is not taken, this branch is not taken. Because if this branch is taken, I'm not going to come here. If this branch is taken, I would not come here. The only way to come here, if this branch is not taken and this branch is not taken. And this branch is not taken if the first condition is true. And this branch is not going to be taken if the second condition is true as well. So if you look at the logic, you will see the only way to come to here is that the two conditions should be true. Any questions? I'm going to make it very simple, guys. Look here. I know maybe it's not difficult, but you need to think a little bit about it. I'm going to make it very simple. What I'm saying is that you have here example for if statement. Okay? And quizzes, exams are open book, right? So if in your problem, if you need if statement, you can come here and see how you made it, and you can use this structure. But for for sure maybe there are some differences. Instead of R1, it may be R4. Instead of 0, maybe you are going to compare R4 to R5, something like that. But you can use the same structure. Even in the coming lab. In the coming lab, I told you need 4 for 32. I'm going to explain 4 right now. How can you make 4, right? So just to go and get the structure from there. So I don't want to overcomplicate things, okay? So also you have here if statement for OR. You have if statement for AND, okay? Let's have more examples. So for example, if I want to do something like that, look here, guys, how I'm going to do it. Look here. You know from C language, I'm going to execute the body of if this condition is true or this condition is true. At least one of them. I don't need to check both. So what I'm going to do right now, guys, I'm going to check the first one. If the first one is true, okay, so I'm going to go to the body of F, and that's what I did. Look here, guys. I'm going to compare. X here means R0. I'm going to compare R0 to 5. If it is equal, okay, if it is equal, go to the body of F. This is the body of F. I don't need to check the second one. The first one is true. Okay, so the whole condition is true. Make sense, guys? Any difficulty here? Great. So if X equal to 5, I'm going to come to here. However, if X does not equal 5, I'm going to come to here. So now the first condition is false. Now I need to check the second one. But the second one, as you see here, because of the parenthesis here, this is one condition. It's one condition. So for this condition to be true, this one has to be true. Here I have to make both of them should be true, right? So what I'm going to do now, I'm going to check, I'm going to see if this one is false, go to end. Okay, that's exactly what I did. So if you look here, guys, I'm going to check here. So I'm going to say if X less or equal 20, okay, go to end, right? Because this one was false. If this one is true, I would not come this way. If this one is true, I would not come this way. If I'm gonna come here if the first condition is false. So now, when you check the second condition, if the first one is false, okay, so you don't need to check this one. False, exit. I'm gonna exit. I'm done, right? If not, if the first one, if X actually greater than 20. Okay, so I'm gonna come this way because if it is less than or equal 20, I'm gonna come this way. If it is greater than 20, I'm gonna come this way. When I come here again, I'm gonna check the second condition here. And again, if the second condition is false, go to end if. That's what I did. If X is greater than or equal 25, just come here. If it is less than 25, come here. So if you look at this structure, you will see, guys, you will see the only way to execute, there are 2 ways to execute this one. There are 2 ways. Number 1, first condition is true, and then I'm going to come to here. There is the first way. The first condition is true. Number 2, these two conditions are true. So that at the end, I'm going to come to here. Because if the first one is false, I'm going to come out. If the second one is false, I'm going to get out. So the only way to come to here, only if these two conditions are true, okay, not false, okay, so that these 2 branches are not going to be taken. Is that okay, guys? Any questions? Okay, let's have more examples. This time I already explained how can we do if statement. Now I'm going to explain how can you do if else statement. If else statement. You know, in if else statement, guys, you have a condition here. If the condition is true, I'm going to execute the body of if. If the condition is false, so I'm going to execute the body of else. Right? This is how if else works. I need to check the condition. It is true, go to execute the body of if. False, execute the body of x. Can I execute the bodies of if and else? The answer is no, you can't. Only one of them should be executed. Okay? Only one. And that's exactly, look at the very simple examples. That's what I did. Look here, guys. Here, I'm going to this condition if equal. Okay, so the way I'm going to do it, again, guys, there are different ways, but I'm going to do this way. I'm going to say, I'm going to compare R1 to 1. R1 is A. So I'm going to compare A to 1. If it is not equal, please go to else. So I'm going to go to else. If it is not equal, if A does not equal 1. If it is equal, I'm going to come this way. If A is equal 1, I'm going to come this way. Make sense? So now I'm going to check the condition. If the condition is false, go to else. If the condition is true, so it's going to come this way. So what I'm saying now, very critical, very important. Listen to me. If you come this way, so here, this is the body of then, okay? If I execute the body of then, so I have to skip this one. So I have to write branch, skip this one. This is too confusing. You know why? I'm going to tell you why. In if statement, you don't need to do this in if statement. In if statement, you used to have like if, then you have the body of if, else, the body of else. Is that okay? That's how we made it, right? So you don't need to write here an instruction to branch. Okay, because this is one statement. This is one statement. This statement is going to execute either this part or this part. But this is very detailed. If you forget, very important, very important. If you forget this one here, again, this is the body of if. This is the body of else. If you forget this unconditional branch, what's going to happen is that if the condition is false, I'm going to come here. If the condition is true, I'm going to come here, execute this one and this one. Why? Because if else statement is not an assembly statement. I'm creating it. You got what I'm saying? It doesn't, assembly doesn't understand that this is body of this is the body of this. It doesn't understand that. You got what I'm saying? So if you forget this one, after you execute this one, it's going to come to execute this one. That's why if you execute the body of then, so I have to skip this one. You can't execute the body, both of them. Okay. Any questions? Okay. Again, I have too many examples here, and I think the best way to understand this part is by examples. So let's see more examples here. Okay. For example, I want to do something like that here as you see in assembly. In C, I want to do it in assembly. Okay. You have a variable X. You have a variable Y. I'm going to assume I'm going to use R5 for X. I'm going to use R6 for Y. For example, register R6. So here, this part in C is going to be equivalent to this part in assembly. Okay, that's okay. Now I want to do this part here. I want to say, I want to compare X to Y. So I want to compare R5 and R6. Okay, remember this one R5, this one R6, and you have another variable Z. So Z is R7. Okay. So now look how I'm going to do it. Just very simple. I'm going to compare R5 to R6. Okay. If less than or equal, okay, which is the opposite of this condition, less than or equal. So in this case, you have to go to else. By the way, this is else. Again, this is just a name. The computer will accept it. If you call it then, okay, you can go to then. But actually, what I'm going to put here, this is just a name. Again, else or then, anything I put here, guys, it's not a keyword. It's not an instruction. This is different from C language. C language, else is an instruction. You have to write else. It's just a label, any name. It doesn't matter. Okay. Anyway, so if the first condition is false, so I'm going to go to the body of else, whatever you call it here. Okay. So here, and in this case, I'm going to put 0, as you see here. This is if X is less than or equal Y. However, if X is greater than Y, if the condition is true, I'm going to come here to store 1, as you see here, to store 1. Again, don't forget this one. Don't forget this one. Again, assembly doesn't know that you are doing if-else statement. We don't have something called if-else statement in assembly. We are creating it. You understand what I'm saying? So if you don't put this one, assembly is going to execute the body of if, and then it's going to execute the body of else. Okay? Because there is nothing in assembly called if-else statement. You are creating it. Anyway, I think here, yeah, this program, guys, okay, Again, when you do this comparison, as I told you before, you have to consider if numbers are signed or unsigned. So this program is exactly similar to this program, but here is but this one for signed numbers, this one for unsigned numbers. You know what is the difference? Only the difference is here. Because this is signed numbers, I used less or equal. And because this one is for unsigned, I'm going to use less or same. Remember, I told you we have an instruction for signed and instruction for unsigned. Everything else is the same. Only here. Which branch you are going to use? Are you going to use signed branch or unsigned branch? Is that okay? So here, these two programs are the same, are doing the same thing, but this one for signed number, this one for unsigned. The only difference is going to be here. Everything else is the same. Any questions? Okay. I just want to show you here, guys, you can do, I just want to give you some examples on conditional execution or conditionally executed instruction. If I want to do something like that, I can do it using branches. I already explained things like these ones. So you can do it using branches, or you can do it using conditionally executed instruction, as you see here. And I'm going to tell you something interesting here. Look here, guys, what's going to happen. What I want to do based on the C language here, what I want to do, if A less than or equal 0, so I want to store -1 in Y, else I want to store 1 in Y. So if the condition is true, I'm going to do this one. If the condition is false, I'm going to do this one. Look how I made it. You can do it using branches, guys, okay? But now I'm going to do it using conditionally executed instruction. Look how I made it. First of all, I'm going to compare R0 to 0, right? Okay, so this one is going to update flex. Okay, this one is going to do subtraction, update the flex. Okay, and then this instruction here is going to be executed if less or equal. If R0 is less than or equal 0, we're going to do this one. So I'm going to store -1 in R1. And this one here, move of greater than. So if R0 greater than 0, so I'm going to store 1 in R1. It's very confusing. No, I'm going to tell you. I'm going to tell you what may be confusing here. Okay, listen to me. Very, very important. Look here, guys. This instruction actually is going to update the flex. We agree on that, right? This instruction does not change the flag because it's move. It's not move S. So this one is going to use this flex to decide to execute to store -1 in R1 or not. This one as well is going to use the same flex resulted from here. So this one, the first to compare is going to update the flex. Next one is not going to update the flex. Next one is not going to update. Next one is not going to update the flex. So all of them are going to use the flex of the first one. That means if you put here S, if you move S, it's not going to work. Because I want this instruction to use this flex. I want this one to use this flex. You got it, guys? So the first one here is going to update the flex. This one is going to use this flex and it's not going to change the flex. This one is also going to use this flex because the previous one didn't change the flex. Okay. Yeah. Also, look here how I'm going to do it. Look here. This also again, some of them are somehow I don't want to use the word difficult, but not straightforward. Here again, I'm saying you can just use branches. I'm totally fine if you can just use branches, but I just want to present the different ways. If I want to do something like that, look guys, how I'm gonna do it. Look here. First, I'm gonna compare R0 to 1. Okay. So if it is equal, 0 flag is equal to 1, this one is not going to be executed. This one is not going to be executed because this one compare if not equal. This one compare if not equal, right? Okay. But if the 0 flag is 0 in the first one, now So that means the first, that's exactly, if the first condition is true and the zero flag is 1, so I don't need to check this to condition, okay? Because it's enough to have only one condition that's true, because this is OR, right? Anyway, but if the first one is false, this one compare if not equal. So if the zero flag here is 0, this one is going to check. If R0 equal to 7, so the zero flag should be 1, and this one is not going to be executed. You understand what I'm saying? If not, so this one will be 0, right? And in this case, I'm gonna do this compare. So I have 3 compares here. Okay. Again, it may work in this scenario because it's just equal. It's just easy. Anyway, so once I come here, guys, zero flag is 1 if any of this instruction is true. So if the first one is true, so the zero flag is 1. If the second one is true, zero flag is 1. If the first 2 are false and the last one is true, zero flag is 1. Okay. The only way that the zero flag here is 0, okay, if this compare finds that R0 is not equal. So after I come here, guys, now I'm going to use the flex. So here I'm going to say move if equal, put 1 in R1, or put -1 in R1. Okay, guys. Again, I don't want to overcomplicate things. What I'm saying is that I want to show you, in my opinion, in quizzes, you can use the easy way. You can use just the branches. I'm totally fine, right? But just so I want to also show you the other way if you want. Okay. So let's have more examples here. If I want to do something like that, if x plus y less than 0, okay? So let's see, because there is something interesting here. Okay, look how I'm gonna do it. Look here, guys. So here I want to add x plus y, as you see here. So what I'm gonna do here, so here you are gonna do the addition. You are gonna do this addition, right? You are gonna do this addition. Okay. And now after here I'm gonna add s to update the flex. Okay, so if you do the addition and the result is 0, so the zero flag, this one is gonna update the zero flag, right? That means I don't need to use compare here, because compare is gonna update the flags. But this instruction itself it can update the flags. It's not wrong to use compare. It's not wrong. However, you don't need it. So what happened here, guys, if you see, that's what I want to see here. Sometimes if the flags already updated, you don't need to. So what I did here, guys, look, I'm gonna add R0 plus R1, store the result in R1. Oh, that's what I did here. It's to x plus y. Okay. And then I'm gonna say branch if plus. If the result, if x plus y is greater than 0 plus. If greater than 0, please come to here. In order, if plus means greater than or equal 0, okay? If greater than or equal 0, come to here. For sure, in this case, I have to put 1, and I put 1 here. If not, so if it is not greater than or equal 0, it means if x less than 0. If less, so in this case, I have to store 0, and that's what I did here. Again, look here, guys. Everything is normal. What is not normal here is if you want to add here, compare, if you want to say compare R0, 0, it's okay. But actually, it's not going to do anything here. It's useless. Why? Because this one is going to update the flex, right? So you don't need this one because flex already updated. But I'm totally fine if you want to just add one more instruction, it's not a big deal, but you should understand you don't need it, right? Because if the result is 0, this add will do it. However, if you use normal add, without s, you must put compare, because the normal add is not going to update the flex. Okay. So again, sometimes if already flags are updated, you don't need compare, and this is an example. Okay. Again, it's the same here. I did it using branches. I can do the same thing using instructions, and that's what I did. Look how I made it, guys. I'm gonna say add S. So this one is gonna do addition, and then it's gonna update the flex. Is that okay? This one is gonna update the flex. Then I'm gonna say move if minus, if the result is minus. Minus means x plus y less than 0. If it is minus, please store 0 here. Okay, and then here this one also move if plus. If plus, store 1. And because this instruction does not change the flex, so these two instructions are going to use the flex resulted from here. Okay, guys. I want to tell you something. This one here, I told you, listen to me carefully. Here, I'm telling you, if, for example, if this one compared to 10, for example, in this case, this one is not enough. You have to use compare. You get what I'm saying? In this case, you can do addition, and then you have to compare R0 and number 10. Okay? It is okay for 0 because I want to check if the result is positive or negative. And this is something easy. I can do it because I have here, I have a branch that can check the negative flag. Okay. It can be also okay if it is equal 0. Why? Because if the result, if the result of this addition is 0, the 0 flag would be 1, right? However, if you want to compare to another number like 10, for example, right? So in this case, after you do addition, you have to use compare to 10. Yes.
Do you still have to leave the S on hand when you do that?
If it doesn't matter, you don't need it. Okay, it's not wrong to put it. You can understand? Here in this example, I must put S. Why? Because I'm going to use the flex resulted from here. But if you use compare, if you put here compare, you don't need S. If you put it, it's not wrong. But you don't need it because you are not going to use the flex. Okay. Anyway, now I'm going to talk about for loops. How can you make for loops? Okay, guys. First of all, let me make a very quick revision on how we made for loops in C language. You remember in C language? You must remember, right? So in C language, we used to do something like that. We used to use like something like I. I is like a counter. Counter. Okay, counter. So you know, I'm gonna start I from 0. Every iteration, I'm gonna increment I. So every time I'm gonna compare I to 10, as long as I is less than 10, I'm gonna keep looping. You understand what I'm saying? So in the first iteration, I is 0, right? Next iteration, I is 1, I is 2, I is 3. And as long as I less than 10, I'm gonna keep looping, right? So here actually, once it is 9, so from 0 to 9, once you come to 9, and then you are gonna exit. Why? Because once you come to 9, you are gonna increment I, becomes 10, and then you are gonna go outside. You understand what I'm saying? So this is how you can make for loop for 10 times. This is how can you make for loop for 10 times. You can start from 0, every time you increment by 1, and here as long as less than 10, keep looping. Make sense? You can do it in a different way. You can start from 1, but in this case, you have to make equal here, right? So if you start from 1, so you have until 10, 1, 2, 3, 4, until 10. If you start from 0, so it should be until 9. Is that okay? You know, there was also another approach. I can start from 10. I can start from 10, and every time I can decrement. Every time you decrement, right? And you can say, as long as it is greater than 0, keep looping. Makes sense? You start from 10, as long as it is greater than 0, you keep looping, greater than or equal, or whatever. Okay. So anyway, so how can we do this? Is in C language, right? How can you do the same thing in assembly? Okay, we don't have for instruction in assembly. I'm going to use compare and branch instruction to create for loop. How I can do it? It's the same idea. I should have a counter like I. Okay, every time I have to increment I. Every time I have to compare I to 10. As long as it is less than 10, keep looping. So number one, I need a variable like I. For example, I can use a register to act. I can use a register to act like I. I'm going to initialize this register with 0. Every iteration, I'm going to increment I. Okay. Every iteration, I'm going to compare I to 10. If it is less than 10, go to the beginning again, keep looping. Once it is done, go outside. So how can you do it? Very simple, as you see here, guys. I decided to use R0 as a counter. So here R0, just give me 1 second. So here R0 is equal to 0. So I is equal to 0. R0 is a counter. I initialize it. Okay. So as you see here, guys, first I'm gonna compare R0 to 10. If it is greater or equal, if R0 greater than or equal 10, go out. I'm done. Go out. Okay. If not, so this is the body. This one is just, if not, come this way. Once you come this way, you are going to increment R0, then go back to here. And here, this is the body. This is the body of 4. So as you see, number one, I'm going to use a register R0. I'm going to initialize it with 0. Every iteration, I'm going to compare to 10. Once it is greater than or equal 10, go outside. If not, so go execute the body. This is the body. This part is the body of 4. Execute it, and at the end, increment R0, and then go to the beginning to check again. You see how I created it? Again, in the coming lab, I just want to tell you, it's just very simple. I'm trying to make it very simple. In the coming lab, you need for loop for 32 times. You can use any, I explained one instruction. You can use this instruction. You have another instruction I'm going to explain next time, but you can just use this instruction. That's it. Okay. And then, but the difference is that instead of 10, you are going to make it 32. So you can use this instruction. Okay. Anyway, so I'm going to continue next time. Thanks, guys.